Hello everyone. Welcome back, and we are going to begin with the second part of the chapter trigonometric functions, and we are going to talk about certain values of trigonometric ratios for the certain value of angles. All right. For example, I have on the board various trigonometric ratios for various angles. For example, we know up till 90 degree. So if you remember what is pi, it is equal to 180 degrees, okay, and it's written as pi radians. All right. Now from here we have sine, cos, tan, cosec, sec, and cot, and up till this range, up till the range of 0 to 90 degree, we all know about the trigonometric ratios of sine, cos, tan, sec, cosec, and cot. All right. So for example, we have cos 90 being 0. Similarly, cosec 90 being 1. All right. Everybody knows about that. But as the angles change, as I told you earlier, we said and we learned that trigonometric ratios are periodic functions. And by periodic, everyone knows, especially those studying in science, know that it's a function whose value repeats after a certain time, or a function whose value is equal for two different values. So for sine example, we have for 0 it is 0. Okay. For sine 0 degree, it is 0. Similarly, for sine 180 pi, okay, 180 degree or pi radians, it is 0 again. Similarly, for sine 2 pi, again, it is found to be 0. Likewise, in case of cos, cos 0 is 1. Similarly, cos 2 pi is also 1. So what is happening? The value, the answer that is being returned, the ratio that is being returned is repeating after some interval of angle. All right. So keeping this in mind, we can say that trigonometric ratios are generally periodic. Not just generally, they are periodic. All right. Now, as we look further, we find for certain angles, the value of the ratio is negative. For certain angles, you can see it is negative. All right. For certain angle, it is negative. So as we move further, we are going to talk today about how for certain angle, which ratio for certain angle, the ratio is negative or positive. So for which trigonometry ratios and corresponding to which angle, the ratio would be negative. Okay? Yeah. So to understand for which ratios corresponding to which angle the answer would be negative, we need to understand this diagram. All right. Now in this diagram, I've divided this into 4 quadrants, where first quadrant is between 0 degree to pi by 2 radian degree. Okay. So from 0 degree to pi by 2 radians, or 90 degree, you could call it, we find that all the ratios are positive. All right. So up till class 10th, where we studied trigonometric ratio, we could only find positive values. The reason being, all the trigonometric ratios are positive in the range 0 to 90 degree. All right. Now, we will write it from 0 to pi by 2. All ratios are positive. Okay. Now for second quadrant, the angle is between pi by 2 to pi, from 90 degree to 180 degree. So what is happening between 90 degree to 180 degree? We have all the ratios of sine theta and cosec theta positive. Okay. Now, as I'm saying, sine theta and cosec theta are going to be positive. What about the remaining trigonometric ratios? So, in the angle between 90 degree to 180 degree, what happens to other trigonometric ratio is they will always lead a negative answer. All right. For example, if I had sine. So between 90 to 180 degree, let's say example 140 degree. So for sine 140 degree, the trigonometric ratio sine for angle 140 degree would be an answer that would be positive. Okay, this is what I trying to explain. But if I have a cos of the angle being between 90 degree to 180 degree, let's say 110 degree, now whatever the value this trigonometric ratio is going to give, the value would be negative. Okay, so this much is clear. So moving further, we have between 180 degree to 3 pi by 2, which is 270 degree. Okay, from 180 degree to 3 pi by 2, what do we have is, we have tan theta and cot theta positive. Okay, clear? Now for the last quadrant, we have between 3 pi by 2, 272, 0 degree, or you could say 272, 360 degree. Okay, so let's say 2 pi. Okay, so 2 pi is 360 degree. So what is positive in this range? What is positive is cos theta and sec theta are positive. Okay, now this is the base on which we are going to build up, and then we are going to find certain angles, certain ratios for certain angles, and we are going to check whether it's positive, it is negative, and what should be the answer. Okay, now this is the base where we are going to start from. First thing, you need to understand this. For angle 0 to 90 degree, all the trigonometric ratios are positive. For angle 90 degree to 180 degree, sine and cosec theta are positive. Similarly, from 80 degree to 270 degree, tan theta and cot theta are positive. And then we have from 270 degree to 360 degree, again cos theta and sec theta are positive. Okay, now that being said, the angle doesn't end at 360. Okay, so from 360 degree to adding up say 450 degree, and then adding up goes on 720. Okay, and it goes on further 1000, 2000, 3000. So what is happening? It keeps rotating, but while rotating you need to know, is it in the first quadrant? If after certain rotation it falls into the first quadrant, then the value of the ratio would be positive. If it is falling in the second quadrant, is it sine theta or is it cosec theta? If it's sine theta and if it's cosec theta, then it will remain positive. Otherwise, it be negative value. Okay. Now, what is the value? We are not talking about that. But what we are talking about is it positive or is it negative? All right. So in this, sine and cosec is positive. So same way tan and cot, and same way cos and sec, depending on the angles between the ratio. Okay. Next, we are going to talk about the values of trigonometric function for certain allied angles. Now, allied angles is when sum or difference of two angles will give me either 0 or a multiple of pi by 2. Okay, so for example, in the first case, I'm placing theta as minus x. Okay, so what happens when sine theta, instead of theta we have minus x. All right, now we are placing minus x instead of theta. So what happens to the value of sine is we are going to get a negative sine x. Okay, so it's clear from the above table where we talked about 0 to 90 being positive, 90 to 180 being positive for sine and cosec, and from 180 to 270 tan and cot to be positive. From 270 to 360 degree, cos and sec is the positive value. All right, so for sine to be minus x, now what is minus x? Let's say x is certain angle between the range of 0 to 90 degree. So in that case, if I'm subtracting from 0 minus x, so that means that instead of going in an anti-clockwise direction, I'm going in a clockwise direction. So minus x will be between the angles 360 to 270, or you could say 270 degree to 360 degree. So that is what minus 30 is. All right. So if I said minus 30, then that would mean 360 minus 30, which is 330. So in this position somewhere. Okay. So for that, as you can say clearly, only two trigonometric ratios are going to be positive for angles between 270 and 360 degree. So sine's value is negative. Similarly, for cos value, it will be positive. Simple. For tan, it would be negative. If you divide sine by cos x, then negative remains. So it would be negative tan x. So for cosec, it would be again cosec negative x. Okay. And for sec, again, the cos and sec are reciprocal of each other. So it would be a positive sec x. Okay. Lastly, negative cot x. So, is it clear? Right. So next, for pi by 2, okay. Now this is an angle that is pi minus theta. All right. So pi minus theta, you need to remember certain theorem that we did in class 10th, where we had this formula sine 90 plus theta, sine 90 minus theta. Okay. So if you remember this formula, sine 90 plus theta equals to cos theta, if you remember. Or instead of plus, what we used in class 10th was sine 90 minus theta equals to cos theta. Okay. So something that is being relative. Okay. So in that sense, if I said sine 90 minus theta is equal to cos theta. Okay. So that is the answer. But what about the sign? Is it positive? Is it negative? So what is happening? We are subtracting a certain value x from 90 degree. Therefore, it falls in this range. Okay. For this range, everything is positive. Therefore, for sine 90 minus x, again cos x. So for cos 90 minus x, we have sin x. For tan 90 minus theta, cot x. For cosec 90 minus x, sec x. For sec 90 minus x, cosec x. For cot 90 minus x, tan x. Okay. So what is happening? Sine changes into cos, cos changes into sine, sec changes into cosec, cosec changes into sec, and likewise tan changes into cot, and cot changes into tan. If the angle that is placed in the function is pi by 2 minus x. Okay. Clear? So keeping it this way, for pi by 2 plus x, sine 90 plus theta equals to again cos theta. Is it positive? For sine value, angle greater than 90 but less than 180, sine is always positive. Okay. So this remains positive. For cos 90 plus x, it would be sine x. But is it positive? It is not positive. It is negative, because for cos, when the angle is greater than 90 degree but less than 180 degree. So this falls in the second quadrant. And in second quadrant, we have sine and cosec positive and cos to be negative. So cos of 90 plus x is negative of sine x. All right. Similarly, tan of 90 plus x equals to cot x negative. Okay. Cosec 90 plus x. Again, what is the answer? Sec x positive. Clear? So for sec 90 plus x, it would be cosec x negative. For cot, it would be negative tan x. Alright. So next one, pi minus x. Now, for certain angles, we need to change it. For example, for pi by 2 plus x, we changed sine into cos. Okay. Now, in case of pi or 2 pi, oh, this is 2 pi. Okay. So, in case of pi and 2 pi, what happens? Sine remains to be sine. Okay. For pi by 2 or 3 pi by 2, sine changes into cos. Okay. Now, how do you remember it? Now, how do you remember it? So, to remember it, the best way is when we have an odd multiple of pi by 2. For example, in this case, the odd multiple, let's say 1 into pi by 2, odd multiple 3 into pi by 2. Likewise, moving further, if we have 5 into pi by 2, 7 into pi by 2, 9 into pi by 2, plus theta plus x. So what happens? There's a change, or you can say shift, where sine changes into cos. Okay, cos changes into sine, tan changes into cot, cot changes into tan. So likewise in that way. Okay, so keeping this in mind, so for pi and 2 pi, now these are even multiples. Okay. So, if we have even multiple of pi by 2, so let's say if I multiplied 2 by pi by 2, so this gave me pi. Okay. So, in this case, what is the value? It is pi minus x. So, similarly, if I multiplied with an even number 4, then I'll be getting 2 pi as it is over here. Okay. So keeping that in mind, when we have an even multiple of pi by 2, even multiple of pi by 2, so in that case, cos will remain cos, sine will remain sine. This would be sine x. Similarly, sine 2 pi minus x would be sine x. However, in case of odd multiple, for example, 1 into pi by 2, 3 into pi by 2, it will change sine into cos. Sine into cos. Now the question is it going to remain positive, or is it going to change into negative value? Okay. So keeping that in mind, again, pi minus x is sine x. What is the quadrant in which pi minus x is going to fall? So this quadrant, pi minus x, would be this region. So over here, what is positive? Sine is positive. It remains to be. Next, if pi plus x is the angle, so what happens to the sine value? This is pi plus x falls in this region where tan and cot are positive, not sine. So this would be negative sine x. Okay, are you able to relate? So similarly for cos x, sine changes into cos x. Reason, this is an odd multiple of pi by 2 minus x. 3 pi by 2 minus x means this will fall in this region. Alright. So over here, what is positive? Only tan and cot. Therefore, what about sine? Negative. Now 3 pi plus x, for sine, angle being greater than 270. Okay. Sine is negative because cos and sec are positive. Okay. Negative. Now 2 pi minus x, reaching beyond 360. Okay. Oh, sorry, less than 360. Slightly less than 360 by x. So again, sine is negative. Okay. Similarly, for 2 pi plus x, sine is positive. So, is it clear? So rest of the table, I'll fill it in the same way. We can check for sine pi minus x. Pi minus x, we have pi over here, minus x falls in this region where sine and cosec are positive. Therefore, it would be minus cos x. Clear? So likewise, we can fill it, and it's clear how it is done. So this is how we get the whole table, and we have completed the table. I think maybe you got it right trying to solve it yourself, and this is how the table is completed. Okay, clear? Just keep this in mind that for odd multiple of pi by 2, we'll have to change sine into cos, sec into cosec, tan into cot. But for even multiple of pi by 2, what is going to happen is that sine will remain sine, cos will remain cos, and tan will remain cot. Likewise for every other ratios as well. Okay. However, keep this in mind that in which quadrant the angle lies and for which trigonometric ratio is the value positive or negative. Okay. Clear? Okay. So based on what we did earlier, I've got two questions for you. For example, first question is you need to find the value of tan 480, and the second part is you need to find the value of sine minus 11 pi by 3. Okay, so up till now you have been doing angles between 0 to 90 degree, and that was simple because all the ratios were positive. But what we are going to do is we are going to move further beyond 360, let's say 480, and keeping that in mind, how do we solve the question? All right, so let's solve the first part. For the first part, we have tan 480. Okay, now I'm going to separate into two such parts where one part will be a multiple of pi by 2. Okay, and next part would be a trigonometric ratio that is familiar to me, in the sense we have trigonometric ratios for angles 0, 30, 45, 60 and 90. So that way we are going to separate it. So let's say if I separate tan 480 into tan 450 plus 30. Okay, now 450 is a multiple of 90 degree. Simple. Okay, so let's convert it into radians and see what happens. We have tan 450 plus 30 as tan 450 is 9 5s are 45, so 5 pi by 2 plus, instead of writing 30, I'll be writing pi by 6. Clear? Okay, now you need to consider in which quadrant it is going to fall. Okay, clear? So 5 pi by 2 means 5 times 90 degree. So 1 time, 2 time, 3 time, 4 time and 5 time. So we are going to reach back to this region. Okay, clear? So this is the point for 5 pi by 2. Clear? All right. Now what is happening is we are adding a certain value beyond 5 pi by 2 by how much? By 30 degree. So this is the region, the quadrant where the trigonometric ratio, the angle is going to lie. So for tan, this value, the angle being greater than 5 pi by 2 means it falls in this region. Therefore, the value of tan would be negative. So before writing negative, what is the multiple of pi by 2 over here? It is an odd multiple. Therefore, tan changes into cot pi by 6. Not just being cot, negative as well. Okay. Why negative? Because it is lying in the second quadrant where only sine and cosec are positive. Similarly, so we have got pi by 6. Clear? Minus root 3 So the answer for the first question was minus root 3. Now for the second part, we have sine minus 11 pi by 3. So sine minus 11 pi by 3. Okay. So before beginning, we knew that sine, if the angle is negative, what happens in the sine case? The minus comes out, or it is minus sine 11 pi by 3. Okay. Now pi by 3 means 60 degree. 11 pi by 3 means 660 degree. So how do we separate this 660 degree? You can separate it as 660 can be separated as 630 plus 30. So why 630? It is again a multiple of 90 degree, therefore 630. So 630 equals to 9 sevens are 63. Okay, plus pi by 3, 30 pi by 6. Okay, clear? So this can be separated as 7 pi by 2 plus pi by 6. Clear? Now where does this region 7 pi by 2 fall? Now again, it's a odd multiple of pi by 2, therefore sign will change into cos. Okay, so first thing, minus this minus as it is, cos pi by 6. Okay, 30. Now 7 pi by 2 means which quadrant is it going to fall? 4 times, okay, 5 times, 6 times, 7 times. So this is the quadrant where it's going to fall, 7 pi by 2. Okay. So this is the quadrant where 7 pi by 2 is going to fall. Now what is being added over here? Pi by 6 is being added. So in which region is it going to be? In this region. What is the value? That is going to stay positive in this region only for the ratios of cos and sec. And what are we trying to find? We are trying to find sine. Therefore it would be negative. Okay. So negative. Let's write it as bracket. Okay. So this minus and this minus becomes positive, cos pi by 6. And as you know, cos pi by 6 is cos pi by 6 equals to root 3 upon 2. So this is your answer. Clear? So that being said, dear friends, this is all I'm going to give for today. And before I end today's class, let me hand over to you certain questions as assignment. And the basic or the logic behind finding the values trigonometric ratios is same as we did earlier. And keeping that in mind, I ask you to kindly solve these two questions where you need to find cos 19 pi by 6 and then you need to find sine 41 pi by 4. Okay, keep this in mind that trigonometric ratios are periodic functions. Okay, that is all I have for you today. Thank you.